The New Future of Making on Mars, a tutorial conference for students. Discover possibilities for you to take part in the exploration of Mars. 5 tutorials, 1 plan for building a science station on Mars, 1 veteran's guess about the future, 1 super interview on hot robotics in Leo, 1 conference summary, 8 subject matter world experts from NASA, top universities, and 3 space companies. Sponsored by the Mars Society of Canada, MakerWorks of Ann Arbor. Organized by 2 Planet Steel. See possibilities you haven't seen before.
In this dynamic and forward-thinking Q&A, Kalind Carpenter of NASA JPL interviews Ethan Barajas of Icarus Robotics, a rising entrepreneur. Their engaging discussion, covering everything from how Icarus is reimagining routine aspects of space travel to the skill sets most valuable for those hoping to enter the field, gives students a rare inside look at the ideas, challenges, and breakthroughs shaping the next generation of robotics. Ethan is truly impressive, and his company is poised to enable manufacturing in low Earth orbit, grow the new space economy, and help lower the cost of payloads to Earth orbit, advances which will benefit the cost of transport to Mars.
All right, fantastic. Well, the question I have to ask first is what hobbies or sports got you into the space industry, or do you love?
Oh, skiing and soccer. That was great. I was on the U.S. Developmental Academy for the soccer team, and I think that high competition, as well as skiing, going down the slopes, doing tricks in the park, like that sort of creativity and competition is exactly what robotics is, right?
For sure. It's also how we inform our internal physics engine, right? We have to understand it viscerally. So
Exactly.
yeah. Well, what inspired your enthusiasm for space?
I got really lucky, right? And I'm the first one to admit it. When I was 17, I got introduced to NASA, first internship ever, and you're working on real spaceflight hardware. That opportunity through that program to actually work on, in my case, an automated plant growth lab that actually gets sent to the ISS, and then work on that project for multiple years before even getting to college, and being one of the youngest technical presenters at the ISS R&D conference, and going through that entire process, seeing your rocket launch, that's absolutely electric. And so for me, that was hooked, from there. And then when I was choosing colleges, I had this amazing opportunity to go to Caltech. And this is the gemstone university that you go to if you like space. And I was super worried. I was like, man, maybe I get siloed into this space thing. So I started playing around with automotive engineering and the whole Formula Student thing. And then I was lucky enough to have 2 internships, 1 research experience over at JPL. And then also Kalind was actually my professor and one of the people over at JPL that worked with us on a mechanical engineering capstone for lunar rovers. And it was at that exact moment where I was like, no, this is truly what I love. I can't wait to be back. And that's what's influenced me to, go start my company, building the robotic labor force for space, raise, $6 million just a couple months ago. And now we're on contract with NASA and some of the commercial space stations to deploy for full-scale testing on the ISS of our robot in Q1 of 2027. So super stoked to be here.
Amazing. So low Earth orbit is becoming this incredible test bed. Commercial space stations and space manufacturing, satellite servicing. As you watch the ecosystem develop, what lessons are we learning now that will matter most when we eventually build infrastructure on Mars and the Moon?
I think the thing is, people have such an underestimate of how valuable it is to actually deploy robotics in environment and have them do things. Even if the environment isn't the lunar surface or the Martian surface, in space is a hard enough challenge as it is. Just launch conditions are really hard to survive. And then you talk about going into vacuum and going into space and understanding the contact dynamics of gravities that aren't Earth gravity and 1G gravity. That's a really tough problem, especially when you get into free-floating objects. And when we talk about going to the Moon and going to Mars, well, to Mars you have this 6-month transit period where you're in microgravity. So you need robots helping clean up the house. You'd be shocked at what astronauts do all day. One of their biggest gripes is just throwing trash away. And then, as we talk about lunar gateway, right? We're talking about 1-month crewed periods here. We're 11 months out of year. This is uncrewed. And you're losing so much valuable science, maintenance, and building things. So it's like these incremental steps where NASA loves to be the frontier and explore everything further. And while we as commercial companies can take the years of learnings from NASA, stand on the shoulders of giants, and really perfect the technology. And so what we do over here at Icarus is we call it kind of a last mover advantage, where we're taking years and years and years of research and we're actually just applying the robotics to get there. And as we get that really, really ironed out, that's what enables us to do those long duration flights. And that's what we're really excited about here at Icarus.
Fantastic. So can you describe for the audience a little bit more about the goals of Icarus, what you're focused on, what your minimum viable product is, and where you see things going in the next 3 years?
Yeah, so I mean, actually, like right here next to me, it's a great prop. We just finished testing one of our robots here. So this is the V2 of our robot, and what it is a free flyer actually. So behind me actually is a little 2 meter by 2 meter air bearing table that the folks over at NASA Ames that worked on Astrobee, which is a free floating camera that films astronauts and can take science payloads. They helped us set this one up with position tracking, so we can get some sort of ground truth of what our robot's actually doing. But the main goal of our company, we realized from even me deploying this autonomous growth lab, I was working with NASA and for NASA, and to get 5 minutes of an astronaut's time to just plug in a 2U experimental box, it was almost impossible. People don't realize that these astronauts have no time. It's $130,000 an hour to keep these guys alive, minus all of the training. These guys come from some of the craziest backgrounds, military backgrounds, PhDs, way smarter and more talented than I'll ever be. And they're cleaning up trash. They're doing seal inspections. They're changing filters. One of the biggest tasks is cargo bag movement. On ISS scheduling, every 60 days we send up about 3.5 tons of cargo in these white bags. Actually, I have one right here. I'm going to go grab it. I should have had this prepped. But so this is from NASA right here. This is an ISS cargo bag, and they were kind enough to send us a decommissioned one. We send up 3.5 tons in those white bags, and it takes a crew of 4 astronauts 7 days to unpack this, and then 7 days to repack it. So out of your 60 days, you're wasting about 14 where you could do valuable science, manufacturing, experimentation, just moving bags. And when you're a commercial space station and you're not subsidized by ISS National Lab and the US government, you don't have the capital to spend on that. You make money one of 2 ways: selling an astronaut seat to someone really, really rich, or a nation state, or doing meaningful science and manufacturing. We're seeing right now, Keytruda, it's a great example. One of the best cancer therapeutics on Earth, made $25 billion in revenue last year. We see massive increases of effectiveness and potential changes from intravenous delivery all the way to subcutaneous. So instead of being on an IV, we can just give it to you like a shot, like a vaccine. And that drug, we changed the way it was manufactured, and it saved hundreds of millions of lives of cancer patients. And that's something that we have from in space. And so that's the science that we want to push forward. And so if we can do those menial, boring tasks that we don't need astronauts to spend their time on, and we can do those with robotics, the boring stuff, the very unsexy stuff, we can unlock not only a bunch of economic growth, but also all of the science that makes space space. There's things that we can do there that we just can't do terrestrially. And that's what we continually learn. So the faster we learn, the faster we find new business cases, whether that be in semiconductors or fiber optics or super alloys. And then we can also study the human body for long duration flights to the moon, to Mars, and what that habitation looks like. But if you have humans, cleaning up and literally using a vacuum, go talk to Johnny Kim about that one. That was a fun conversation we had about how annoyed he was at having to vacuum the hab. If we can keep our talented astronauts from not doing that and doing real science, that's what we're really excited about. And so we're lucky enough to work with a lot of the commercial space stations to take care of those menial tasks so the astronauts that they send can focus on that science and focus on generating revenue and real value.
Amazing. That brings up 2 questions for me, the same kind of beginning. So you've talked about some amazing futures for the space industry, specifically in Earth orbit. We also have, we've got Lunar Gateway, so we're not only going to have VAST around Earth. Varda's cooking up, drugs in space. We have Lunar Gateway as we get out to the moon. We've got all of these lunar bases, Mars bases, things like Blue Ring, and each of these has unique capabilities. Out of all of these, is there one of these that you think is the most exciting for Icarus? And then the second prong of this question is, what is no one doing that you're hoping gets done in the near future?
I think the most exciting thing about all of these platforms and what we do is we're very platform agnostic. So the architecture of our robot is designed in specific to be platform agnostic because all of these platforms suffer from some of the same things, the same sort of maintenance things that you see on any station, the same sort of science tasks that you see on whether that be an automated facility like Varda or a crewed facility like VAST or your Star Lab or your Axiom or your Orbital Reef, whatever that might be. They all see the same things with different systems. And the funny thing about these commercial stations is they're all building on top of the legacy of 25 years of ISS awesomeness, right? For 25 years, we've done science in space, and there's a lot of stuff like that cargo bag that I just showed you that's been around for 30, 40 years, and no one wants to change it, number one, because it's already been safety qualified and you don't want to spend the money on it. But number two, it's worked. Why reinvent the wheel? Like, let's push forward the stuff that's actually new and exciting. And so at Icarus, we're able to actually interface with all of these things and actually work with all of these companies. And even in cases like Varda or Space Forge or even Redditus, some of these re-entry vehicles that aren't crewed, our robots actually are able to add more capability on top that they wouldn't have had before when they have to rely purely on microfluidics and they can only focus on pharmaceutical sciences. And so now, when you actually have manipulation inside of your uncrewed capsule, you can actually look at things like fiber optics, like semiconductors, and some of those things that previously you once needed a human to do it. And now you can actually have a robot. So we're unlocking capability. And then I think the one thing for me that I wish that we saw more and more folks doing is building I guess the best way to describe it is co-design. You want your environment to be co-designed to interact with the robot. And we've been lucky enough to partner with these commercial stations at this perfect point of the CLD Phase 2 program, or the Commercial Low Earth Orbit Destination Phase 2 program, where they're going through their PDRs and CDRs to put out their flight modules. And when you look at someone like VAST with Haven 1, because they're so close to deployment, they've already done their primary article qualification for that nice pressure vessel. But everything on the inside, they haven't quite developed yet, and they're still working on it, and they're on a super tight timeline, which, hats off to them. But what we can do is we can say, hey guys, that cargo bag that hasn't changed in the last 30, 40 years? What if we did change it? What if we designed it for a robot? And so there's tabs instead of zippers, or there's actually Aruco markers or April tags that our robot can then look at the bag, understand what's in it instead of like a handwritten note. I mean, you'd be so surprised. Like, they have handwritten notes of what's in here. That's the way that they categorize what's going on. And so
Like
if
QR
we can have exactly, if we can chuck a QR code on there, we know where everything in the station is. And so that level of co-design would be so exciting for us to see.
Yeah, fantastic. So I'll make sure I work with Johnson on this bots before boots idea, where we're making sure things get standardized so that the upkeep and then maintenance of everything can be done. Sounds like you're already talking to all the same people. Make sure you're included in all of those conversations. I have another question, but for many of the people here, what skill sets and opportunities do you see for the next class of the space industry?
I think the most exciting thing is we're in this golden age. We're kind of in our own Apollo era. I missed it. I was born after it. You get to watch all the videos and all the documentaries, and that's the thing that gets you excited about it as a kid, where you look up and you're like, people have been on the moon, and your parents tell you about it and how magical it was. And we missed that boat for as amazing as it was, and now what we're seeing terrestrially with robotics and what we're seeing with, to throw a buzzword on it, embodied AI and physical intelligence, right? We're seeing this massive technological resurgence that's allowing new technologies that we've never seen before. And for the first time ever, launch costs aren't prohibitive to people actually trying things out. And we can actually, with our robot, we're going to deploy it multiple times to the space station. I guarantee this thing breaks on our very first deployment in 2027. That's the plan. We're going to push it until it does break. But we only have that ability because of how democratized launch has been. And so it's this perfect storm of this amazing amount of new technology that seems like science fiction and this amazing ability to actually get to space and access it. And so when you think about what we're doing in the future and what the best skill set is to have is, I think, number one, just starting from a base point, is curiosity. Like having the curiosity to try something new, and just instead of being like, this could go wrong, this could go wrong, this could go wrong, what if this went right? That sort of mindset, right? What if this went right? And then having the ability to just throw your hat in the arena and try things out. But like if I were going back and studying again and working on like something other than Icarus, the thing that I would really focus on is actually like robotics. I think it's one of the biggest industries that'll unlock like massive amounts of humanity that we don't know what's happening. And I think it will be probably one of the largest and most important fields in the next 100 years moving forward. And so if I could go back and actually add to my option instead of pure mechanical engineering, I would definitely go add robotics. Obviously, like with my job right now, I get to work on it all the time and learn from some of the best. But I wish I got to go learn from a more fundamental standpoint and learn about VLAs and VLMs and how we can apply, AI to robotics and actually add autonomy in ways that we've never seen. Right now, after the Polaris Dawn mission, we're seeing sub-100 millisecond latencies of communication from Earth to stations and space vehicles to spacecraft that are 3 times the distance away of the ISS. And we're seeing companies like Muon Space sign contracts with these massive constellations like SpaceX with Starlink and their plug-and-play laser team, which is their laser-based comms team, that we're seeing, greater than 25 gigabits per second of downlink. This is unheard of. We still use S-band radio to talk to the ISS. That's 800 milliseconds, like 1.5 seconds of latency. And so when you have that level of low latency comms with that high bandwidth, what does that unlock? And for us, that's high speed, high dexterity teleoperation, where we can train our own models and own foundational models to do tasks with autonomy. And so that's a super exciting thing that's never been done before in space. And we get to do that and be the first people to try that out, which is super exciting.
Amazing. I think you'll probably be helping to write some of the books on how we do embodied AI, especially in space. So I think there's a lot of learning on the job ahead for some of these, new curriculums that have yet to be written. But yeah, I have one final question for you. This is a little out of left field, so feel free to, just roll with it however you want. What would you like to see as the very first sport in space?
Oh man, you know what I think would be really interesting, and I think this could be controversial. I would love to see any sort of like of like racket based sport. We're talking like tennis, we're talking like pickleball, squash, something like that. I think the dynamics would be hilarious. I think seeing people flounder around trying to reach over would be hilarious. I think it'd be more comedy than really good sport, but I think it would be really, really fun. Either that or something like Real Steel, like flying fighting robots or something. I think that could be cool too.
Love it. Well, let's get some of these into orbit by 2028 to coincide with the Olympics.
What's your answer there, Kalind? I'm curious. Is it skiing or snowboarding?
No. My answer actually is actually working on it, and it's the conversation. So I've spent a lot of time on this where you can suspend, the disbelief we have with something like Quidditch. I'm not saying it should be that, but you can start inventing something that has never existed, right? And so as you start pushing on something that's never existed, you're like, wow, where do we start? And when you can't react the same way we're used to, you're right. First of all, people are going to flounder. It's going to be really interesting. But then you start looking at things like skydiving, and you are definitely in the ultimate skydive when you're in orbit. It is a never-ending skydive with Earth right below you, right? That's the extremist of the extreme sports I can possibly imagine. So what do you do at that point? Do you have some like full orbit 90-minute parkour? Do you have something where you have a real lightsaber with robots coming at you? I mean, there are some pretty epic things you can imagine, and I think we can actually realize them in the near term.
That'll be so exciting. I don't know. We're definitely gonna say our robot flew at Mach 25 on the spec sheet.
As you can. Fantastic. Well, I think it's time to open up for questions. Does anyone in the audience have any questions for Ethan? And congratulations, man. Really excited about all the work you're doing. Well done.
Thank you, Kalind.
Two of you, it was a very nice interview. You both very, you're on the mark. I'm very impressed with you, Ethan. It's the first time I've met you. Anyway, it's extremely exciting. I like the last question. I'm thinking, how people are never talking about how to do sports on the moon or Mars. I think I'm all for lowering the cost of everything, and at some point you could start paying for it all just by pickleball or TV of pickleball.
You understand.
Yeah. Anyway, so yeah, down to like just your the basics of Icarus. It sounds like you've got this huge momentum behind you with this $130,000 an hour for an astronaut. How much can you do with your rover right now? What can it do on the ISS or VAST or VADA? What are the kind of tasks that your robots are capable of?
Yeah, it's a great question. So, in the very beginning of us starting the company, we didn't build anything. We sat down and we talked to NASA ops planners, researchers, astronauts themselves who have been more than kind with their time. And we really wanted to figure out, what do they actually do in a day? And we found there's this team that's called the ISS Playbook team, and they have literally every 5 minutes what goes on a space station. And some of the biggest time sinks are things that are seal inspections, where you're taking photos of seals between nodes. You're changing filters, which is literally just swapping out filters in front of the air circulation system. You're changing actually the water recycling filter. And the biggest of all of these is cargo bag movement. It truly does take so much time of an astronaut's day just moving these bags in and out. And some are priority, some are cooled, some need to go to the Merlin locker immediately, the freezer. And so obviously we can't really mess with those. But the things that aren't time priorities, well, these astronauts, they need to eat, they need to sleep, they need to exercise. They're on a standard schedule. And so now you imagine a world where these robots go in and they take care of the logistics while these astronauts are doing the things to stay alive. And they can actually say, oh, hey, my cargo in my experiment is in the exact spot I need. And instead of me having to run around, Tom Marshburn, a very famous astronaut, we meet with him very frequently. He said, anecdotally, if I take 2 hours for a science experiment, the first hour and 30 minutes is just going to those bags to find stuff. And so that became a very, very clear problem for us to try to solve just from a pure science aspect. And then we learned the unit economics behind it and how expensive their time was. And we said, whoa, well, hold up. The ISS is deorbiting. There's these commercial stations launching. There's talks from these SpaceX folks about laser-based comms. This seems kind of like a perfect storm. And as we talked to these commercial space stations, we found that, oh my God, actually, ISS National Lab and NASA subsidize a hell of a lot more to make this $130,000 actually palatable for the commercial sector. And for these commercial stations, it's anywhere like $250,000 plus, right? Wow. And for them, they truly are stuck in these two operational modes. You sell astronaut seats or you do things, whether that's science or manufacturing. And just from all of these conversations that led to just these really massive tailwinds for us and the right partnerships at the right time. But very recently, Sean Duffy came into NASA and he changes the acquisition structure for the CLD grant. And, in some cases, people look at it and they say it was good. In other cases, people say it was bad. And I'll leave that up for you guys to evaluate. But the one thing that it opened the doors for was uncrewed periods during commercial station operations. And since 2019, we've been talking about commercial space stations filling the gap of ISS. And since 2019, we've stuck true to the continuous heartbeat memorandum, where just like the last 25 years, we're going to have an astronaut above us in orbit continuously. And this was the first time that we stopped looking at that. And there will be a capability gap where we don't have astronauts to do science. And immediately off the back of that change and that acquisition and that contract, all of these commercial stations were actually reaching out to us and saying, hey, you guys have been the annoying guys pitching us in our ear robotic labor for space stations. Holy crap, I can't sell astronaut seats for the better part of the year, and I can't do any science unless it's automated. You guys have been
Okay.
talking about automation. And so that really has pushed us forward and allowed us to look at the science aspect just over the last few months. And so that's something that we've been able to work with some really cool people over at Redwire, over at some of the free flying. I think Redwire has very famous pillbox, but some of the free flying pharmaceutical companies experiments as well, and have mock-ups of, you can't really see it, but mock-ups of like experimental payload lockers that we just drag over to the air bearing table and are able to play around with.
Are your customers Varda and Vast and let's see, what's the this inversion or what have you? Are the people with the boxes in orbit wanting to have more utility to their craft, and they're your main customers, or is it the customers of these guys, Varda and Vast, who are your customers, or are they both?
It's definitely the platforms. Like right now, like we're on contract with the platforms and NASA for our first full-scale deployment, and this is to be almost a capability for that platform to lure in more commercial customers. Because if you have more capability, this is much better for the commercial side. But also, we'll be the first people ever, like I was mentioning, to actually do dexterous teleoperation in space and bag that data. And when we bag the telemetry data as well as the video data of the robot actually doing the task, if you look at your favorite humanoid company or your favorite robotics company terrestrially, the way that we train autonomy right now is we take that video data and that telemetry data, and that in the video, the physics of what the robot's doing is actually embedded in that scene. And we can train these like embodied AI models to, chuck the buzzword to it. But like these, whatever it is, whether it be like a VLA or something on the RL side, like this allows us to train autonomy. And so there's actually people outside of the space station, outside of the pressurized volume, that want to do things like refueling, in-orbit maintenance, manufacturing,
Okay.
and all of these companies need that data because there's this big problem of dynamic coupling. As soon as I grab something or move my arms forward, my center of
Hmm.
mass shifts out of my vehicle and I'm free
Hmm.
flying. And when my mass is super, super low, that's a really hard controls problem to solve.
Hmm.
And so if we can solve it in a nice pressurized, a nice safe environment where there's an astronaut to fix it when it breaks. We don't have to worry about temperature gradients, the vacuum of space, solar radiation pressure, all of this sort of stuff. It's directly applicable to all these other folks. And so that data partnership is a great horizontal for us to expand out to and apply more capability to the entire industry, not just these platforms. So it's very horizontal as well as vertical. Obviously, if we could vertically integrate and all the whole thing as a company, we totally would. But you have companies that have built amazing EVA hardware that have been around for far longer than I've been alive. So I don't think I can compete there.
Okay. Oh, have you any idea of the length of time it'll take for manufacturing in space, and the idea of putting a data center in MEO? How long is this going to take? Are we waiting 3 years, six, 10? When are we going to like? When is VAST going to put something up in Leo?
Well, I mean, the cool thing about Vast is they're very much a startup. And they started in 2021. They moved super, super quick, and that's why we like working with them. Haven Demo, which is basically everything but life support for Haven 1, just launched a few weeks ago. And we were down in Long Beach, talking to them, and we got to see the mission control and everything, which is like super exciting. You're not a space company until you send something to space. So I don't consider us a space company yet, and in 2027 I will. And that's the great thing about Vast. And for them, it seems like they're on timeline for May of 2026 launch of Haven 1.
Okay.
They're moving really, really quick. And, for what they're doing, it's very admirable. Obviously, it's not close to the capabilities of ISS, but it's an MVP. That's what it's for. It's to keep astronauts alive, and it's to be a proof of concept that, hey, we can do this commercially, and we can expand it out to have the capabilities of ISS. And that's what it's for. And so when you have people like that are pushing the boundaries, moving super fast, that's exciting. It's exciting to see aerospace companies stick to their timelines and then not slide down into the right like always.
Well, a question I'm really interested in is the effect of Starship and the length of time it's really going to make a big impact. You know, Vast, I think, is working off the Falcon 9, and everything's dimensioned to that. Are they already planning something for Starship? And do you see all these things? You don't have to give me any details, but and is that going to affect your business? That the fact that it's going to have this huge jump in scale? Is there more robots you can make for in a bigger space?
Yeah, always, always. I think one of the biggest things with aerospace, and Kalind and I discussed it a lot in undergrad when we worked on the rover project, is like dependencies, right? If you're dependent on other things happening, you're
Mm-hmm.
just waiting on something to deploy. And I
Right.
think that's something really clever about Vast. They designed for an extended Farron Falcon 9. We have this right now. They can launch with it right now. You're not waiting on Starship at all. And that's something that they did really, really well. And they took that bet, and it seems like it'll pay off. And when Starship does come online, I think one thing to know is like the first customer of Starship is Starlink. And this will always be
Right.
true. It's the cash cow. This is how SpaceX makes
Uh-huh.
money. And every time that the Pez dispenser actual like specifications were sent out to about 5 companies only. I don't know if I could say that, but they were sent out to about 5 companies. And out of those 5 companies, it's to get them to understand, hey, we're not making any bespoke or exquisite delivery system for you. This is what we have you guys designed to it. Because SpaceX is then going to have to design a new delivery mechanism for whatever large volume vehicle or satellites or whatever it might look like. And that takes time. And so, like, even if Starship is entirely operational tomorrow, you're looking at 1-2 year timelines before it's different payloads. And so that
Mm-hmm.
definitely affects other people, and that's kind of the dependencies that we're talking about. But once you do have that capability of mass, totally. I mean, you look at Starlab and what they're planning. That's a 7.3 to 7.8 meter diameter space station that's launching. That's
Mm-hmm.
massive. That's really, really big in comparison to kind of what we have now. And so when you have that, you have increased capability. And when you have increased capability, you can do more things. And if you can do more things, you need more people and you need more labor. And this, compounds and compounds and compounds. And it makes a case for robots even more. We've only had 700 astronauts in all of history. There's only about 100 active right now. And I love to do this. If you take the Earth as a model, half of the Earth's GDP is labor. It's people doing things.
Mm-hmm.
And if we look at the space industry and the way that it's growing, you have to make the bet that labor is going to be a massive part of it. And then you have to look at what we've done in the past and say, well, as cool as it was dragging like Andrew Fustel out on a tether and having him go fix Hubble off of a space shuttle with a wrench, we're probably not going to do that for data centers or space stations or any
Right.
massive infrastructure in the future. So for us, the case for robotics became very clear.
So you with me that this picture of just loads of people on the ground working away on computers in mock-ups, in simulation, in analog sites here on the ground, and everything's so, almost everything's being done robotically in orbit and on Mars and the Moon. Is that what we're going to see for the next 10 and 20 years? Just a huge growth in people, um, in LA, in Nevada, in Texas, in Florida, um, uh, just
In New
doing
York.
all sorts of. There's so many tasks you can do. I think all of this data center stuff at 800 kilometers up, it could potentially just I mean, well, I'm using a bad word, but rocket off economically, just blast off with everyone wanting to have power for AI. And in the United States, it takes a long time to build a power station in the United States. And SpaceX needs some really big projects to be able to fill up. Musk is talking about like a thousand starships, the lift capacity of 1,000 starships. Let's say he's massively off on how often you can lift the starship, but if you can do it, 50 times a year, that's 50,000 starships a year. How what is going to, you need an enormous business to fill up all those starships.
Yeah, that's definitely a Muskism there.
Yeah.
But I think like there's like two things. Is like number one, we're gonna see this kind of interesting period, which we saw with Falcon, which was you now have this capability that's launching very repeatably, very reliably, that's opened up business cases. And so the new kind of space economy that we saw come with Falcon was people finding the business models that actually generated revenue, and was a real business model in the space industry. And a lot of that is, telecom, sensing, the stuff that we know today. And we'll see kind of that same period where people are like, oh shit, I have a lot more volume to space, a lot more readily accessible. What business models does this unlock? So we'll definitely see that. But us at Icarus, what we see is actually, the more robots that you have in space, the more humans you have in space. These things are symbiotically tied.
Oh,
It's not like
okay.
we're going to have robots entirely take over for humans. There's
Mhm.
things that humans have to do that we can't have robots do now. If you think about factories on Earth, we don't even have fully autonomous factories terrestrially yet. So to say that we'll be able to do it in space, that's a crazy hard problem. We're struggling enough as it is to move bags around. That's also a really, really hard problem. And so when you have the humans do the things that create the business models for the robots, for the factories, whatever that looks like, they're needed. We just want them spending their time on figuring out what those are and figuring out, what human biology looks like for long duration space flight, rather than wasting their time, literally like cleaning up the kitchen. And
Right.
so that's the way that we look at it. And there's definitely going to be this big transition period that we see, as orbital data centers launch and things like that. I'm sure Kalind has some thoughts on it as well. I think like the biggest argument for the orbital data centers thing is like you send them to sun synchronous orbit, the radiation's too much for a human, so you have to have the robots do it, right? You have way better power
Hmm.
there. But yeah, I'd love to hear what you have to say, Clint.
For the data centers or just manufacturing in space in general, there's a couple things. One, manufacturing in space, you get vacuum for free. So if you look at how we make all of our chips today, we do atomic deposition, we do all of these different things that require hard vacuum. Well, you're sitting there in a hard vacuum. So there's this ability to start doing some huge batch processing, potentially even growing better crystals, larger crystals. There's a lot of fantastic opportunities on that side of things. For the data centers in space, when I initially looked into it, because I actually was working with Rendezvous Robotics when they were starting up, I was over doing some work with the Aurelia Institute. I never thought data centers made that much sense because they produce a lot of heat and it's hard to get rid of heat in space. But the thing that then made a lot of sense to me when I reassessed, you don't have to pay for land in space. And then it's just an engineering problem. So if you start doing something like Rendezvous Robotics has, and you start making it so it's a temperature pass through, which you can definitely do, you can start harnessing huge amounts of solar energy, and essentially you just now have this area scaling law that allows you to absorb the power, get rid of the heat, and then do all of that processing. And you just keep scaling. And I was like, oh, I get it. So I think we're going to see a lot of things like that. I think there's a lot of really interesting places where what people are realizing is if access to space is fairly cheap and we can get these things that are easily replaceable or modular or upgradable, then we're going to need to start building out these larger and larger arrays. Plus, getting there early means you kind of claim it. With how it works, this feels to me like the Wild West where everyone would run out to stake their claim. So, I was working with some people trying to do infrastructure on the moon. You build that infrastructure, it's yours. What do you think we're doing with these 100-year power plants that is in the president's budget to be built, right? No one's going to be able to get near that, but, us for putting it there. So as we're going through this, you're trying to figure out, first of all, what the scaling laws, who the first customers are. But then, as everyone has been pointing out today, NASA's only going to pay for 1 month a year. You're only going to have astronauts 1 month a year, whether this is Lunar Gateway or whether this is on the surface of the moon. So the industry needs to come up with 11 months of customers, right? And so, the way that I was thinking about it with some friends at the Collective of Space Minds was what's a good example of this in the past? And you take Florida, maybe 4 feet above sea level. It's sandy. It's got all sorts of crocodiles and mosquitoes. And somehow Florida convinced all old people with excess money to bring their life savings to Florida because it was better for their arthritis. And they convinced all families with any leftover money to take their family trips to Disney World. So if you think about this, you're not going to break a hip at a retirement home in space. You just move down the gravity well over time. You don't have to worry about that. You can waltz, you can tango well into your later life, right? If you wanted to start getting into a real, you don't have to suspend disbelief, you can go to Star Wars Land Space. And instead of having to build one regionally, it's orbiting every 90 minutes. So you can access it in 8 minutes to space, and then, let's say within those 90 minutes to rendezvous and dock, and you can actually get a family vacation that you will never forget, right? And you only have to put one in. You don't have to build an island. You don't have to get the permits. You don't have to worry about tsunamis, all of the things that we have here. So the more I've started thinking about it, and I've reached out to these companies actually to start having conversations about what could be done to open up customers in space instead of, right, what we have today is we use our phones, and our phones are getting everything from space, but most customers don't care, right? I want to know what the weather is here on Earth. I don't care that the information came from space. I want to contact my friend over there. I don't care that, it went through a space relay. I don't care that, digital cameras are a space age invention, or, some of the battery tech or even solar technology, because all of these things do make our life better on Earth. So when people say space for the betterment of Earth, we're actually living it today. But I think there's this other side. Where do we transport people's minds instead of, just aid what they want to know terrestrially? Where do we transport people's minds to space? How do we get everyone to be able to go along? So
it's Mars. That's what it is.
Yeah.
People get excited about Mars.
Well, maybe. I think people get excited about space travel, but to date, we haven't given them a platform that allows their minds to ride along other than their imagination. Where's the avatars, right? Where's that real time or close to real time, just time of light delay VR experience? Where is that, sporting event in space? Where is that first actual, televised, some type of musical, production in space? Who's going to be the first musical artist to perform in space, right? I think there's some things where billions of people will be watching, and they'll be transported right there. And then their minds will actually imagine them being there. And it's going to start flipping the script on whether people just want to stay in the gravity well or venture beyond.
One of the craziest things that we've had, and I can't say who it was, but we had a very rich person come to us and say, when is the first time that I can just, like our operator interface is VR long distance. You can be in the robot, you can fly it around, you can manipulate it. It's just like you're there. It's almost like an embodiment in the ISS. And he's like, how can I pay for 1 hour slot where I can just fly this thing around and have fun? And we were like,
Yes.
oh my God, this is like, yeah, sure, always you can give me money, right? Like, great. But we never realized that this is something that, people are actually looking for. And we're privy to a lot of the conversations that go on for the utilization of some of these commercial crew slots on some of these commercial stations. And you'd be shocked at how many of them are from the sporting world, the entertainment world, Hollywood. It's quite crazy. And I think truly that is going to be a massive use case that we see open up, because it's one of those things that just drives excitement. If we're honest, space has a bit of an optics issue right now. Kalind and I, we were just talking about this as well. We're going back to the moon for the first time in years, in about what, two-ish months? And people don't know. You mentioned the Artemis
Hmm.
program to people, and they say, "What? No way." And so
Right.
any way that we can bring that sort of, the childlike wonder that everyone once had into it and really transport them and
Hmm.
put them in the environment is so key to the rest of the industry. And some people point at it, they say, "Oh, this is so snake oil, yeah, yada yada yada." But like, if this is the true first use case that we can actually make commercially viable, everything else then follows. And
Hmm.
like that's super important.
Thank you very much, both of you, for doing this. It's been a great interview and a Q&A session. I've really enjoyed it.
Thank you,
Thank
Rolf.
you all.
Much appreciated.
Yeah.
You have just heard a talk in the conference for students, The New Future of Making on Mars. People like you are taking part in the exploration of Mars. You can too. This online conference is sponsored by the Mars Society of Canada and MakerWorks of Ann Arbor, Michigan, and organized by Two Planet Steel. Please like, subscribe, and watch more conference videos.